Ruse is awesome, by the way. I told him I was cold this morning, gave him his jacket. I've been wearing it for like 3 hours. It's fantastic. So, is everyone excited? No, it's not good enough. Let's try that. Everyone excited? Woo! Yeah, all right. There we go. That's what I'm talking about. So, my name's Karim. I'm from Meta. I'm from the productivity org specifically. We help people move fast and safe, and it's great. Fun quick note about my avatar over there. So thank you, Peter, for cropping out the beautiful macaw that was on my shoulder. I feel bad about that one. Also nicked a bit of my hair. I don't have a lot of that, so I'm not very happy about that one. All right, big team, lots of folks. I'm not going to go through everyone. Akshay's here, so hi, Akshay. All right, so before we go through any slides, why are we here? We're here for 2 reasons. A, measuring productivity is hard. And B, finding ways to improve that productivity, equally hard. So today we're going to talk about measuring productivity. We're going to talk about a use case with Debbie the developer. We're going to talk about her velocity, her reliability, her knowledge issues. We're going to talk about a few other metrics. We're going to show you our dashboard, because everyone has a dashboard these days. And then we're going to talk about what the future holds. So how do we measure productivity? I'm a developer. I like simple solutions. I build software, design software. I need them to be simple. So I figured, you know what? Let's have a single metric. Yes, that's what I was waiting for. All the grimaces in the audience. It's the same face. You're like, oh, no. Same face you make when you see an athlete run into a wall. I predicted the grimaces, by the way, and I put that one up there. Yeah, metrics are hard, and there are a lot of them. I did a bunch of research. I found all these. Some of them are terrible. Some of them are OK. I see some more grimaces. That I don't have an athlete this time to show you, but these are not good. Some of them can be dangerous. Let's talk about why and how. So a good friend of mine told me about a story about a language server. So language server, if you're not familiar with it, it's an API, sits behind an IDE, feeds your IDE with information of like what the function definitions are and all that jazz. So here's a quick example with call the function. And it shows you a little pop-up. It shows you the function itself. And you can see that same function below it. So my friend was telling me about the story. And he talks about the latency of this. So the latency of this call was 10 seconds. Now that's pretty horrible. You can't really do anything with 10 seconds. So their goal was to reduce it. And they did. They reduced it down to 10 milliseconds. Which is great. So I asked him, how's productivity after he reduced it? He told me people weren't much more productive. And I was like, why? Turns out it was 10 milliseconds, but it was actually just wrong now. And that's completely pointless. So the reason I tell this story is it's important to make sure you don't over-index on the wrong things. Right? Again, if you focus on latency, you might miss accuracy. Now, this isn't a story from Meta. I say this both because it isn't a story from Meta and because legal wouldn't approve the deck if I did. Let's talk about DORA. So DORA is a productivity framework. You have deployment frequency, you have lead time for changes, mean time to recover, change failure rate. This is basically a productivity framework meant to measure team efficiency. Now, the first thing you should notice, first thing I noticed, is the letters don't match. That's OK. That's because it actually stands for DevOps Research and Assessment. And so this team was created by Nicole Forsgren, I believe, 2014. The metrics came out 2017. And it was great, but she figured we can do better. So she set up another team at GitHub, or excuse me, Microsoft Research, I believe, and they developed the SPACE framework. SPACE has a number of different metrics. The idea here is to measure more holistically how productivity is going. And so they published this in March 2021. It was Nicole Forsgren, Margaret Ann Story, Peggy, Chandra Mandela, Thomas Zimmerman, Brian Hogue, Jenna Butler, a bunch of folks. It was great. So what's Meta doing? Well, it wouldn't be a proper deck without an XKCD, so hopefully everyone's seen this one. The idea is you have 14 standards, and folks are like, oh, that's ridiculous. We got to combine them, have a single unified universal standard, and then you get 15 standards, because that's how that works. So instead of adding to the pile, we decided to take a step back and look at the problem. So let's do that. Let's talk about Debbie the developer. So Debbie's a dev. She works on the .com website, otherwise known as the Blue app internally. Not that one. There we go. So she wants to fix tech debt. So she steps an entire week. She blocks everyone's calendar. And she decides, let's fix all the code. So what can she pick from? She can pick from a dozen things. Let's do some audience participation here. Who migrated a framework in the last 6 months? All right, now my favorite part. Who is still migrating that framework? All right, yep, yeah, all right, there you go. So lots of things to work on. Possibilities are absolutely endless. So how do we help her? How do we tell her what code is problematic so she can fix it? Let's talk about code. Can anyone tell me what this is? What does it do? What does it solve? It's FizzBuzz. It's FizzBuzz. So it's a nightmare, right? Like, trying to understand that is a pain. What about this code? A lot simpler, right? So you can optimize for a bunch of different things. You can optimize for readability. You can optimize for speed. You can optimize for, I don't know what that one's optimizing for. So let's talk about speed. Let's start with speed. How would we go about measuring speed? So I wanted to solve this problem. I remember the words of a very smart woman in my life, which was basically, trust your instincts. Well, my first instinct was to give up, so I assumed she meant my second instinct. My second instinct was to start with velocity and see what we can get. So before we talk about code gestation time, just some background. If you were here earlier, you heard these terms as well. A diff is basically a PR, and landing a diff is basically pushing a PR. I'm going to use that terminology because that's what I'm used to. So CGT, code gestation time, is meant to measure how many working hours does it take to produce and land a diff. And so what we do is we look at when a dev starts working on a diff, and then we measure up until that diff lands. And then there's going to be a lot of noise with that. Calendar time is going to be very noisy. And so what we do is remove all the time when the user's not there. So lunch, PTO, weekend, holidays, anytime the user's not there, we just cut that out. And that creates a much more stable metric, which we call CGT. So the big question is it correct? Well, it's time. It's kind of hard to argue, but we wanted to argue for it anyway. So we looked at a few situations. We looked at CGT for the company around the holidays. And you can see that with company holidays, with performance reviews, CGT tends to spike. This is not because people are out on vacation. It's because they are blocked by folks who are out on vacation. Or it's because they are there and they're working, but they're working on performance reviews, on thoughtful feedback for their peers and managers, and self-assessments, right? So they're not actually shipping code. We also looked at tenure. So at Meta, when you start at Meta, you join a boot camp. And so what you end up doing is you work on very small, guided tasks meant to teach you how it is to develop at Meta, teach you all the tools and all that jazz. And so you can see CGT, the time it takes, is really low in the beginning, under 6 weeks. After 6 weeks, a boot camper will graduate, and they'll start working on a team. And what they'll run into is they have to learn about all this new code and all these new processes, maybe some tooling that they didn't experience in boot camp. So you can see CGT spike from there. It goes down, it kind of stabilizes around a year, and after a year, folks have hit their stride. So they know what they're doing, they're familiar with their tools, et cetera. They know the XFN partners, things like that. All right, let's talk about Wasabi. So Wasabi is a Python language server, not that one. So Wasabi had a huge latency reduction while preserving correctness, not that one. And they launched to a subset of users, and they wanted to see, does this affect CGT? And it does. So they noticed that the time it takes to author code between the group that experienced the improvements in this Python language server versus the group that didn't, they found a 20% improvement. Now, there's a QR code. If you're interested in reading more about this, there's a blog post about it. I'm going to give you about 10 seconds, and then I'll move on. And so make sure to take a photo, save this, and then be completely distracted for the rest of the talk. Don't listen to me at all. And time's up. All right, let's talk about one more story. We're a little bit short on time, so I'm going to skip right through this. Basically, a big complexity reduction, and we saw improvement in CGT. Yay. Not a lot of time. So we know diff CGT. We know the time it takes to write a diff. How can we use that? Because it's not very valuable on its own. So take a look at an example. So we have diff1. Diff1 CGT is about 3 hours. We know the files in that diff, right? So in this case, file A and file B. Let's add a couple more diffs to the mix. We have diff2, diff3. Diff2 took 9 hours, 3 took 1 hour. We can actually start to weight the CGT and then apply that to the different files. Now I'm going to use averages for this. Please don't use averages. But I'm going to use averages for this talk just to simplify things. So by this logic, let's take file edits into account. Let's say file B was edited twice, and the CGT for each was 3 hours and 9 hours, so 6 hours. all of a sudden you have sort of an effort spent kind of weight. I'm being very vague in these slides to simplify. And that's about 12. And you can do the same thing for file A, that's 3, and do the same thing for file C, that's 1. All of a sudden you can start to rank how much time folks are spending on specific files, find the hotspots effectively. And again, please don't use averages. Back to Debbie. So her team was planning on working on friendrecommender.php. She noticed it was expensive to work on. But she opened her dashboard and she realized, oh, actually, there's a file that's more expensive, friend generator, at about 300. Excuse me. Now, the reason for that was recency bias is hard. You work on a file. You haven't touched friend generator in a month or so. You've forgotten how painful it is to work on. So what this allows her to do is actually find the hotspots in a quantifiable, objective manner. All right, so we can measure time taken to write a diff and attribute it to files. That's great, but velocity is not everything. So let's talk about reliability. In fact, it's been a while, and Debbie's team is now underwater. So she can move really fast, but she's stuck fixing a bunch of bugs, a bunch of stuff, and it's just painful, right? So how could we help her find the problematic code in terms of reliability? For that, we're going to have to start categorizing diffs. So what if we could find the intent of a diff, the reason it was created? diffbird. There'll be another QR code here in a minute. So diffbird is a model built around diffs. It can see more data when we'll talk about that for now. It can actually tell us what is a bug fix, what is a feature, what is a tech debt improvement, et cetera, et cetera. And we're using ML because nobody's going to categorize their own diffs. Like, I don't do that. I don't think anyone will. So speaking of ML, no, QR code first, 10 seconds. Now, speaking of ML, I have a fun story. I was on SageMaker for a bit, and there was a notebook there to talk about how ML is actually better at figuring out what plants are which than humans. So let's have a vote here. We're going to look at parsley and cilantro. So who believes that that is parsley? Show of hands. All right. By definition, half of you are wrong. Who believes that that is parsley? Okay, so everyone who raised their hands is correct. They're both parsley. That's cilantro. Yeah, I couldn't tell either. All right, let's talk about CGT and reliability. So we have CGT for a diff. Now we have intent. Let's take a look at the same diffs from earlier. If we can categorize them as these are bugs and these are features, now all of a sudden we can figure out, okay, well, file A has had, I simplified this a lot as well, has had 6, say, hours of bug CGT, whereas file C had 1 hour of feature CGT. All of a sudden you can actually track which files are the most expensive in terms of on-call load, in terms of bug fixes, things like that. And what's more is you can do the same thing with bug count. So we talk about CGT and velocity. You can actually start tracking this file has had X problems in the past, in the last 6 months, for example. All right, back to Debbie. So Debbie used that information to stop the bleeding, which is great. She's shipping features, fixing bugs, designing legs for avatars. It's great. But she's worried. She's worried because all the information is starting to silo. In getting out of drowning, they ended up siloing the knowledge. And so Debbie is the expert on credit card processing, but her teammate Shrek is actually the expert on gift card processing. I'm going to pause for a minute. That's actually Shrek. That's an early concept of Shrek. So I ruined my own childhood. I'm going to ruin everyone else's here. So she doesn't want the knowledge to be siloed. She asked the team to write 2 wikis each, and then nobody reads them. That didn't really help. So how can we help her? Let's talk about knowledge for a little bit here. What if you could tell her exactly what files are starting to lose knowledge? Well, we can. Surprise. We can. So if we take the authors and the reviewers of specific files and then cross-reference that with the folks that are still on the team, you can actually start to build a data set of who has knowledge on specific files. And so, for example, in this case, you have Debbie and Shrek. Debbie and Shrek have knowledge on the UI layer. Debbie's an expert on credit cards. Shrek's an expert on gift processing. Nobody uses bank processor for some reason. Person left. So we can actually tell Debbie, you know what, these files are at risk of folks leaving. So you can look at a chart of how many files are about to lose knowledge and how many of them are safe, if you will. So that's great, but what if we didn't have to wait? We didn't have to have Debbie do any manual work. That'd be great. If we could just do it for her, spread the knowledge automatically, that'd be fantastic. Let's say we actually recommended reviewers and had that just automatically spread the knowledge within a team. That'd be fantastic. Now, gotcha, we're not actually doing this yet. We are recommending reviewers, but we're not using knowledge diffusion yet. So that's one of our next steps. All right, let's talk about some other metrics for a bit. Very briefly, we talked about velocity, reliability, knowledge. There are so many more. We can look at code quality metrics, all the static analyzers, test coverage, code complexity, things like that. You can look at the work type breakdown. How much time are folks spending in meetings versus coding versus gathering context, right? Focus time. Focus time is incredibly important. How many gaps of, say, 2 hours or more does a developer have? And more than that, how much time do they actually have uninterrupted? Because you could have a block of 2 hours and you could just interrupt yourself every 5 minutes, which, by the way, is what I do. It's like, oh, do I have any IMs? It's a problem. Then, of course, you can look at tooling duration, how much your build runtime is, your test runtime, all that jazz. Very, very important. All right, so I don't actually have any data on this slide, but there was a really cool template for a MetaQuest headset, so I just put it on there. I literally have no data on this slide, so you'll just have to stare at a blank screen for a bit. Super important, don't tell your devs what to do. I've seen this before, not at Meta, but I've seen this before, where folks will just say, you know what, everyone has to reduce their code complexity by X amount, or to X amount, and that just doesn't work. So here's an example. Let's say you're a cart team at rainforest.com. The problems that you have to deal with are not related to the complexity of your code. Generally speaking, the complexity lives in the infrastructure layer, right? And so that's where your life is. So telling that team to reduce their code complexity is not really going to get you anywhere. They already have low complexity code. Take a look at a different team, say tax. There are 195 countries in the world, 50 states in this one alone, each one with hundreds of rules about tax. I made up the hundreds number, I don't actually know. A lot of rules around tax. Telling them to reduce their code complexity is going to be impossible. It's not going to get you anywhere. So again, having a single person dictate and prescribe what everyone else needs to do is just not going to get you anywhere. Instead, take advantage of everyone's brains. You're paying your devs a lot of money to come up with all these ideas. Trust them. So my recommendation is give them, say, 10, 20% of their time to do whatever they think makes sense. Because they're going to be the experts in their field, and they're going to be able to figure out exactly what makes the most sense to go ahead and fix. It could be test coverage, it could be code complexity, it could be meetings, it could be whatever it is. So we talked about Debbie, but really, Debbie was just a placeholder. These were real teams at Meta. Now, when I say real teams, I mean many, many different types of real teams. I'm going to talk about personas, which is actually what's on the slide for a second here. In my org alone, there are dozens of personas. Every developer is different. A lot of developers in this area will start to think, oh, I'm a developer. I know how all my users are going to act because I'm a developer, they're developers, but that's not how that works. There are so many different personas. As a developer, you need to know your customer. You need to know exactly who you're building things for, and you need to put yourself in their shoes. That's incredibly important. One size does not fit all. All right, so we have all these metrics. How do we show them? I'm going to talk about the team productivity dashboard. Again, everyone has one these days, so I might as well talk about them for a bit. We wanted to build a tool where action was at the forefront. We want to make sure that we didn't just show you some data and think, oh, that's cool. Here's an analogy that I like to give. Let's say I could tell you exactly how many dishes you've tried over time. Right? It would probably be an increasing graph, hopefully, because logic. And your first reaction would be like, okay, neat. Now what? Well, now what? Your first question should be, how do I compare to others? So I've had X dishes. I am above friend A. I'm below friend B. That's great. Your next question should be, what do I do with it? Right? Do I want to increase it? Do I care about it? And the next question is, how do I increase it? How do I reduce it? Whatever it is. How do I keep it flat? Because you can go eat for 24/7 for a little bit to get all the dishes up, or you can be smart about it and have a new dish every month or so. So we wanted action at the forefront. We decided to group our metrics into productivity metrics and investment area metrics. So productivity metrics are going to be things like velocity, on-call load, sentiment, right? Things that indicate the overall health of a team, but not things that you want to change. Because you can't just go, not directly, because you can't just go, hey team, move faster, or hey team, feel better. I mean, you can, but you shouldn't. So instead, we wanted folks to invest in the investment area metrics. These are going to be code quality metrics, tooling duration, documentation quality, in-code, wikis, what have you, meeting hours, focus time, all that jazz. And then improving those is going to improve the overall team health, happiness, all that jazz. So this is a heavily sanitized dashboard. It's a single page, so it looks a little bit boring, to be very honest. But we have a layer where we show all these metrics, and then you can deep dive into every specific one to understand, how can I improve this one? How can I reduce my meeting hours? How many of my meetings are one-on-ones? How many of my meetings are interviews? How many of my meetings are just blockers? How much time do I actually have to work on code? All that jazz. All right, we're going to talk about what's next. We're almost there. Y'all are troopers. So what next? We want to predict things. We want to be able to predict not just what code you should work on, but what kind of fixes you should make. Like, we can highlight file A, file B, that's fine, but we want to also be able to say, hey, removing this deprecated module is going to allow you to move faster because it's blocked you in the past. Or refactoring this class out is going to reduce the amount of code churn in this specific file, number of authors that are working on it and conflicting. We want to do that. We also want to predict exactly what kind of improvements, not just tech debt, but hey, you're in a lot of meetings. You don't need to be in this many meetings, for example. And then we want integrations. Oh, I forgot to, OK. And then we want integrations. So we also want to bring these directly to the developers. Having someone go out to a different tool to understand what to improve, it works, but it's not right there in their face. So what we want to do is integrate with the IDEs, show, hey, developer, you're working on this file. By the way, here's kind of a problem. You should fix it. If you click this button, create the diff for yourself, and you can get started right away. We're going to do the same thing with, say, calendar, right? You're about to block someone's focus time pretty badly. Surprised we do this. You probably shouldn't. All right, so Q&A time. I have a hidden slide, so if folks ask the right question, that one will pop up. Thank you.